Hi, welcome to this particular session. And in this video, I'm going to be showing you everything you need to know to get started with Python. So Python is a very multi-purpose language that can be used to do practically a whole lot of things. And over the next couple of hours, we're going to be walking around how you can become very useful using Python. And that's what we're going to be talking about. So if you're somebody that's interested in getting into data sciences, or you're interested in getting into probably artificial intelligence, or you're thinking about machine learning or web scraping, web development, everything we're going to be discussing in the next couple of minutes is definitely going to be really useful for you. And that's really going to give you a massive edge for you to get started with Python. Without wasting much of the time, I'm going to start by displaying what we have. We're going to learn Python step by step, and this is going to give us some kind of edge on how we can move from no experience in the next 1 hour down to having kind of a real understanding of how Python is being displayed. And the first thing I'm going to answer right now is what is Python? Now, Python is a programming language. It's just think about it like kind of a way for human beings to give instructions to computer, and kind of look at it as instead of speaking English to a person, you're speaking kind of a readable language to your computer. All right. So Python is just kind of a language that is synonymous with the same way you communicate to an individual. That is how you communicate to the computer. So Python is used in machine learning and AI. It can power websites and web application. It can automate some boring tasks, and it contains some kind of beginner-friendly syntax, which we are going to be discussing about in our session today. So Python also has a very huge global community. There are a lot of people who are actually using Python. So it's a language I really, really recommend for anybody who is getting started with it. Okay. And the analogy here is that imagine you want a robot to make you a coffee. You can't just say make coffee in Chinese if the robot only understands English. So Python is the language that your computer already understands, and it reads it almost like plain English. Now, we're going to talk about how to set up your Python before we write any code. Uh, of course, we always have kind of a place where we write it, and there are lots of options that are quite important. There's something we call the IDE editor and all of that, which I'm going to talk about in jiffy. Now, the first thing I'm going to do right now, getting started in Python, is that I'm going to come online here and I'm going to search for python.org. And of course, it's going to bring me to this particular uh, layout. And I could just click, I want to download the latest Python version. And yeah, you can go through Python's documentation. You choose the particular part that is compatible for your operating system. I am running Windows, and definitely you can just kind of go through the documentation of Python, understanding how to get started with it as beginner. There are kind of some documents about what it contains. You can just navigate around this part, still gives you some kind of information about where this. But for us to get started, we're going to just go to download. Once we put download here, we'll go to Python install manager, and automatically it's going to start, install some kind of packages for us. Okay. And if we want to actually get a standalone installer, we can still click here. And of course, it's going to start installing Python, which is compatible to my system. So let's just talk about community. There is a kind of large, Python community, and yeah, it's a very, 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 very massive programming language that gives you some kind of access to so many uh, like-minded developers in that community. Okay. So if I've gotten that, I'm going to just click on that. And already what it's going to do now, it's going to pop out a window where I have to, right now it's asking me to upgrade and all of that. You don't have to click customize installation. You can only touch it if you know what you're doing. But then if I'm not interested in that, I could just click on this and of course, it's going to set up the process and have the whole package actually installed for me. Okay. All right. So I'm going to just kind of give it some time for the installation to work. For some time, I might just decide to return back to my to my slides. So after we are done installing Python at python.org, which is free, of course, we're going to choose an editor and we're going to install an editor. VS Code is one which we are going to use, or we have Anaconda. So the first option there is that we can just go to Anaconda Python download, anaconda/download. And this is where you can actually download, Anaconda. You can also go through the documentation. It has an open source. It's open source, meaning that everybody can, kind of access it. And what we are definitely trying to track now is the Jupyter Notebook for our maybe more of for our where we're going to code or write our, an environment that's going to give us access to write our code. Okay. So I'm going to install that, which I already have that installed, but I'm not definitely going to be installing that. You could just click on skip registration, and of course, it's going to actually let you download. You can click here. It's this for Mac. If you're using Linux, you can actually use this. We're using Mac, Linux, or Windows. Okay, that's what I mean. All right. So of course, you're going to click on Get Started for you to install Anaconda and all of that. Okay, this is where you kind of sign up. Okay, that place where I clicked before is where I'm going to get the Anaconda package. So when you click Anaconda, you can come to your okay. So I'm going to cancel this because I already have Python installed in my computer. And now the next thing I'm going to do right now is to launch your notebook, which is kind of an option. I can come here and click Anaconda prompt. It's going to pop out the Anaconda prompt. Then I'm going to kind of create a folder and then copy my folder to the path here, which is going to launch. Once it launches that path, I'm going to copy my folder there and then actually give my command prompt, which is going to, I could just maybe kind of change it directly, CD, then put the folder path that I want to launch. And that's definitely going to launch the Jupyter Notebook, which I'm not going to be doing. Now, okay, I'm trying to close this, but it seems to be kind of stubborn, so I'm just going to push it to one side. Now, for this tutorial, I'm going to be using the VS Code. How do you download VS Code? I'm going to come to VS Code download. And once you search for VS Code, you can just open this particular first line and, you click on Windows or you look for the particular code editor that is compatible with your system. So for mine is VS Windows. I'm just going to click on this and of course, it's going to give me direct download link, which is downloading right now. I don't need to download that. And once I download it, of course, I'm going to install it, but I don't need that. So I'm just going to close this. So once you get open your VS Code, this is what it gives you. And I could just kind of broaden this file. I'm going to show you what a new file looks like. I could come to open folder and I could maybe go to my desktop and right here on my desktop, I could just right click. I could just say new. I could just say maybe project folder. Okay. And I'll enter that. And then I'm going to just select folder. Now, this is exactly what you're going to do once you're getting started. But the reason why I'm doing this is just so that we can actually see this. And then this is what it's going to open. Once it gets this open, I could just quietly close this and create a file. I could click here to create the file. It's definitely going to work. But then I could just want to click here too, which is also another option. I could also right click, and then it gives me an option to create a new file, whichever approach. But then that's it. I'm going to call this project dot. Now, what I'm going to now, just pay attention to this extension here. I could use project.py, okay? And it's going to give me a Python file. Now, after downloading VS Code, I mean to say something. There is another thing that you need to do. Because we are running this on VS Code, which is our code editor, you have to come to the extension here and install Python extension. Now, what this extension does is that it helps you in your code editor to identify that Python has been installed. So you can see here now it's already installed in my extension. If I click on install, it's going to install, but I don't have to do that because it's already installed. So that's what you need to do. Now, I'm going to close this. Now, if you want to use the interactive Python notebook, which is a Jupyter notebook, you can also come here and also make sure you install that extension. And that extension is going to be Jupyter. Okay. So once you click on Jupyter, it's going to pop out this extension as well, which I also have installed here. Now, what this does is that it gives you kind of an access to write your code using the interactive Python notebook, which I'm going to explain soon. And also, so this is also another, useful extension, the Jupyter Notebook renderers. But you must make sure that this first one here is installed, because if you don't install it, it's going to be difficult for you to run, code in kind of segmented, terminals, which I'm going to explain that soon. So I don't need this. I think I could just do without that. I'm going to click on this. And now there's also another code editor, another IDE. IDE stands for Integrated Development Environment, which we call the PyCharm. So you can just go on and search for PyCharm, download, and it's actually hosted by JetBrains. And when you get into PyCharms, you're going to find out that it gives you some kind of access. I'm going to set cookies. So depending on your operating system, if mine is Windows, if it's Mac, you can choose Mac. If it's Linux, you can also choose that. So I'm just going to kind of download. So if I click on download here, I'm going to download it, but I already have that downloaded. Installation process is the same. Next, and you get all of that done. Now I'm going to show you what the IDE looks like. I also have that here. And I think I'm going to be, kind of switching from one IDE to another just to make this very interactive. This is what the IDE looks like. PyCharm, I could just copy out all of this. Okay, just a second. So kind of, so I'm just going to delete all of this so that I could create fresh ones so that you see how I'm definitely going to do it. Okay. All right, so this is how it launches. Now to create a file, I'm going to come here. So I'm going to click here. So it's going to give me create Python or Jupyter notebook, so whichever one. So I can create anyone here. I can try to create a Jupyter file, and I'm going to call this main. Okay. So once I click on main, it's going to give me the main.interactive Python notebook. And you see automatically it opens the Jupyter cell where I can now run code. So I could here do something like print welcome, and of course the package is being installed. Just give it some time. Okay. and can I give it some time to install and all of that? So it's quite installing. Now, another alternative I could do here now is I could come here and I'll click on, okay, sorry, excuse me. I could click, okay, it's trying to install that, but yes, I'm just going to kind of force it. Now, so this is the first one. I'm going to also show some examples. Now, I could also click this. This is one option, interactive Python notebook. So I could just click on Python here. I could say uh, learning.py. Now, watch the extension, and automatically it's going to give me that. Okay, and this is where I could run my code. I could say print, welcome to this tutorial. And I'm going to click on run. So this is where you have to execute your code. Sorry, I think something, okay, we mistakenly didn't complete that installation or something. So I'm going to kind of collapse this because of the time of this video. I just want to kind of make it simple. So let us see what we can do here. If we say print, welcome, and all of that. And of course, it's going to display on our screen so you can see it here. Welcome. Okay. So this is one IDE. So now the reason why I show you this is just for you to understand that this is what also another type of IDE. All right. Now, for the Visual Studio Code, which is what I'm going to be using for a large majority of this project. Now, this first one is the normal Python extension, where once you run execute your code, it comes out of the terminal. This is where you can execute it. And I could just decide to use, say, okay, practice dot interactive Python notebook, okay? And okay, there was a mistake in my spelling. I'm kind of going to rename it practice.ipymb. All right. So everything that I just explained right now is what you need to get started with Python in terms of installation. Now, we're going to write our first code, which is definitely what we have done, printed welcome. So whenever we run this code, it can display whatever thing that we want. Now, we're going to talk about variables, okay? And what do we mean by variables? So variables is kind of a labeled box where you store information. You give the box a name, you put something inside it, and you always open it later to use what's inside it, okay? So Python remembers the value as long as your program is running. Now, Python is one that is dynamically typed, okay? Which means that you don't really have to state what's the type of variable that you have, whenever you assign it. I'm going to explain what that means. So just kind of think about it like a computer's memory shelf. I have name is equals to David, age is equals to 25, print name, David, and all of that. So I'm also going to talk about some kind of naming conventions, which is quite important for you as somebody who is getting started with Python. Okay. Variable name should be in lowercase, descriptive, have no spaces, use underscores instead of first name, student's age, and all of that. Okay. Now back here, still explain what this environment means. So if you're approaching this particular session as a result that you want to practice some sort of machine learning, here you could print, we could say use this markdown. So this markdown is basically where we make comments. We could say variables. So everything about our code is going to be represented in our Git repository, and we're going to be making comments while we proceed. So yeah, exactly. I have a Python file here, and I also, I could just come and say print David is the, I'm going to just come. Maybe this is a good boy, and of course it prints that. So I did Shift Enter to print that. Now, here we could start by saying names is equals to, now this is a container, right? So that is what this means. So I'm going to say David, age is equals to 35. So this is also another, this is a variable, this is a variable. Now, I could just print name, okay? And I could go to the next line and print age. And it gives me 35, okay? All right. Now, the reason why we're doing this now is because we need to actually understand some certain information that if it was to be in C or JavaScript or whichever other language that is statistically typed, you could say something like int name is equals to, or I think I'm going to say maybe something like string name is equals to David, okay? For example, this is just kind of an example. And then you can also print this. So what this means that maybe it goes to something like uh maybe int age is equals to maybe 27 or thereabout. Then you could say print this. So the point I'm trying to buttress here now is that you're just trying to make sure you assign the type of variable together. But Python is one that is quite very smoothly written. You could write something like, what are the your friends' name? Okay. You could see how we are typing friend name is equals to maybe Chiamaka, or you could say for example, you could say friend surname is equals to maybe Eugene, and you could say print my use an F string, which I'm going to explain also. My friend's name is, you see, friend name, and surname is, we're gonna pass the second variable, say friend surname, okay? And then we print it, so my friend name is Chomoka, and surname is Eugene. So that is variables, okay? So the idea of variables is that we use it to store objects. So if I come again and change the friend's name now as maybe Cynthia. Now watch, if I print friend name, it has now changed it to what? Cynthia. Means that it's running line by line. So when it came here, I now change it. So this is small, that's why we call this a container, okay? So a variable, you see, is a container that holds some information and releases that information whenever it is stored. Okay, so it's mutable. Why is it mutable? It's mutable because we can try to change it, remove, add, and all of that to this particular container. Okay, so that's what a variable is in Python. Now, the next one I'm going to look at now is what we call data types in Python. Now, what do we mean by data types? Now, not all data is the same, okay? And I'm just going to just copy this and kind of put this here. I think we'll just close this terminal. We don't need it again. And I'm going to say, maybe create a markdown for that. Okay. Now, when we talk about data type, what are we talking about? Not all data is the same, okay? So Python uses different data types to store different kind of information. So just like you would use a different container for water versus sand, okay? Python uses different types for text versus numbers, or true versus false, true or false values, okay? So that is what we're going to be talking about right now. So variables is the container that holds these data types, right? Now, first of all, we have a string, text is wrapped in quote. Anytime we have any text that is wrapped in quote, then that means that is a what? That is a string. For integers, we have kind of whole numbers, no decimal. Age is equals to 30. If you wrap this in string, it becomes what? It becomes a string, okay? Now also I will call floats, which is numbers with decimal points, all right? And any number that have the decimal point is now a float. And we have Boolean variables, Boolean data types, which is what? True or false. Now let's check out this now. So we can also check out this by doing type of variable, and it's going to show us the class. So now let's check out this now real quick, okay? So first of all, we talk about name, right? Now I've shortened it as John, okay? And we'll say age, we'll say BMI, okay, which is 56.63.65.3, and then we'll say class. No, now we don't, okay, I'm going to also talk about reserved keywords, okay? I'm going to talk about that in my next reserved keywords, okay? Now let's finish with data types. So we have maybe we could say uh, uh, level, level, level. We could say is in year 1 or year 100, and then we could say is this person a student? We could say true. Okay, so we're gonna print name, and of course it's gonna give us John. We could say print BMI. We could say print level. We could say print is student. And of course, it's going to give us John 65.3 days. Now, we talked about data types. Now, like, can we now know what this type of data is? Now, what we can do right now is I'm just going to kind of copy this. I copied that with Control C. And I'm going to just come down and I'm going to paste this. I'm going to call this data types. Okay, and I'm just going to pass inside of this a function which is called type. So I want to know the type of name. What type of name is this? I say type, and I'm going to pass again type. And then I'm going to pass another one, type. Okay, just make sure that these brackets are all clear, okay? So I'm just going to print it. Now, you notice what it returns. Now, it tells you that this is a of class string. That's name. So it means it's a class string. Now, how do you know strings? They have some kind of quotation in it, okay? And then we look at the next one now, BMI, which is in decimal. It tells us it's of declared float. So float are decimal data types, okay? And then we look at the next one, which is level 100, which is just a number, is of class integer. And then the last one, which is Boolean, which is of class Boolean. So that means this could be true or we change it to false, okay? Can only take 2 measurements and nothing changes. Now, we're going to talk about printing and formatting outputs, which is the next thing we're going to be talking about. Now, but I want to kind of let you know something about some naming conventions and reserved keywords in Python, okay? And naming conventions in Python, okay? Now, this is what I'm going to be talking about today, and now, whenever you're naming a variable, if you want to assign a variable, you see the first time we say names is equals to maybe Sarah and all of that. Now, it's always ideal to start with lower case, okay? Make sure you start with lowercase. Now, in a situation whereby you have something like name in class, one name in class. Now, this is not going to be possible because you don't need to have spaces. So you need to separate it with underscore and underscore. Name in class is big girl. So the first rule starts with lowercase, use underscore to separate uh, kind of a multiple name length, or you can say longer names, or longer names that you want to have, or longer variable names. Okay, because it's that variable name in lowercase, so that's good practice. And now we're going to look at some kind of reserved. Now, what do you mean by reserved keyword? Now, there's some certain words that you cannot use in naming, that you cannot use in naming your variable, right? So before that, I'm also going to say don't uh, can I say don't start a variable, don't start a variable with a number. Okay, so we can have something like one name is equals to Cynthia. What happens when we run this invalid decimal extract? Because we don't need to start this with a number. Okay, so we don't start, but you can keep the number at the end. Name one is equals to Cynthia, and when you say print name one, it's definitely going to print Cynthia. Exactly. So this is kind of a better practice, okay? And now we're going to look at now you see that when I you see that when I run all of this, right, I'm actually appending what we call comments. So what are comments? Comments are what you can use to give some sort of signal to your programmer. I'm also going to add that here, just to be sure. Comments. So comments are what you use to, kind of create some documentation or information about your code. So what more like once others goes through that particular code and maybe other developers that you're collaborating with and all of that, and they see the comments, they can be able to identify what you are doing. Okay, just like as I'm saying here now, telling that you need to start with variable, name variable with lowercase. If I print this now, this line is not going to run because I commented it out by starting with an asterisk. There's also another way for us to give advanced, or more like multi-line comments. We are going to talk about that in the other part of this video. All right. So that is for comment. Now for reserved keywords, okay. Now there are some certain words you cannot use to assign a variable. You can't use the word like for, you can't use the word like in, you can't use the word class, you can't use the word def, you can't use the word try, you can't use the word except, okay? And you see that while I'm writing out these words, they are popping out. And you see that the color now differs from the normal color of this variable that I assigned in. That is to tell you that they are what we call what? Reserved keywords. They are words that you will use in doing your programming. So you cannot come and start using it to assign or to name a variable that you want to use to store information. So we don't use this particular we don't use this particular we don't use this particular uh we don't use this particular naming conventions. whatever, if that is clear to name our variables. Okay. Yeah, so we have accept, we have a lot of them. So you kind of just check out the documentation. Uh, I've talked about it in my previous video. There are lots of them that we do use in naming our our variables. Okay. So I kind of just comment that out so that because if I run that, that's gonna throw up even it's just there are a lot of them. Like I said, there are so many of them. Now, we were talking about printing and formatting output, how to print output. So with the something we call the print function is the way it's kind of it's just kind of a way of showing output to the screen. Okay, you can print plain text, the whole value of a variable or combine both of them together. This is how you communicate results to the user. So the only way the user is going to see what we are talking about is by we printing it and it appears on the console. All right, or maybe it displays on your screen. Okay, so that is how we communicate with the results to the user. For example, my name is this. I could just print my name is name. Okay, so this automatically is going to take out that variable and unpack what is stored in it. Okay, so that is how we basically perform our print. So I'm just going to show you something very useful that you might want to have kind of an understanding on. And I could just scroll up and I'm going to add a markdown. So, for example, we could have weight. Okay, and I'm going to print. Now watch, I use a quote inside of the print function. Let's see, my weight I'm gonna add a comma, I'm gonna add weight, and it is 78.2. Okay. So my weight after I checked it yesterday is 78.2. Now, there's also another called the F string, which I might want to kind of show you. And let me say I want to add more information here. Maybe probably I could see um, network and I assign it to MTN. I want to say, now listen, print F string. So I'm going to call the F string. And instead of it now, I'm going to pass in, I'm going to say the network that I am using is, I'm going to pass a curly braces inside of this, and I'm going to put network. The network I'm using is network. And I realize that they increased my, okay? Now this is what we call what? F string formatting. We call this what? F string. Okay, we'll zoom on that. So that's how it works, okay? You'll find out that so it prints exactly what you are interested in. Okay, so the network that I'm using is MTN, and I realized that they increased my maybe my weight. Let me so whatever. That whatever way that makes sense or not, but the idea is just to kind of understand what he's talking about. Now we're going to look at user input, okay? How we can make the program interactive. Do you understand? So our programs now used data we typed ourselves so far, but a real program asks the user for information, and that's what we call the input function. Okay. So the input function pauses the program and waits for the user to type something, and then you now press enter. I'm just going to show you what this is all about. How it works is that the message inside input, you pass the message inside the input function, and then it pops out as a prompt. Whatever the user types in is stored in the variable. Maybe in this case, it could be name, because you have name and you say input, enter your name. What it does is that anything you type here, it will store it as a variable in name. And then when you print hello, its name, it will now give you the that's what is contained inside of that variable and you stored in name. Okay, instead of everything that's contained inside of name variable. So kind of important thing to note here is that input always returns a string, even if the user types a number to do math with, you need to convert it, which we're going to talk about in the next slide, and then practice, I'm going to ask you to enter your favorite color and say you have to print, oh, this color is good or not. So let's kind of show you an example of what that illustrates here. I'm going to add a markdown here. I could say, um, color is equals to, now I'm going to say impute, I'm going to say please enter your recent best color. Okay, and I kind of just put the semicolon here. And so I'm going to say, print, and maybe you could say food, impute, enter your best food. Okay, and yeah. Now look at what I'm going to do now. Let's just make it more, okay? We could say title, we say name, impute, what is your name? So now I'm gonna print all of this, and then we can say something like maybe number is equals to impute watch, impute, enter your best number. Now, essentially, everything that this is going to print, including this number, is going to be stored as a string. Do you understand? Everything here is going to be stored as a string. So if I come and say here, okay, print hello, Mr. Name. Okay, hello. I'm going to wrap this thing in the curly braces. Let's put an F string. So I'm going to say Mr. Name. How are you? Okay, and okay, I just kind of added a new line there. I'm going to say, okay, print here my best color. Instead of, okay, see, your best color is, okay, color. So I'm also going to call print your best food is food. Your best number. Okay, so we're done. So I'm going to run this. You see, it displays here, what's your name? My name is David. It asks me again, what is your best color? I could say red. What's your best food? I could say Gary. What's your best number? 6. And that's it. So you see it. Hello, David. How are you doing? I don't think this is necessary. Your best color is red. Your best food is Gary. Your best number is 6. Okay, so that is how it works. So, but now let us say we want to say print uh, something like type of number. Now watch. Now, what do you notice here? We asked the user to add the number, and it added the number. But then when we now printed the number, try to print the type of number, it's telling us that it's of the class what? String. So it means that this number here now, this particular number 6 that was printed here now is not even an integer. Okay? It's not even an integer and it's of the class string. So the question now becomes, how do we convert it? Let's say we want to build an input program that is going to tell somebody's age in the next 5 years. Let me say, for example, say age is equals to input. What is your age? All right. And then we'll now say new age is equals to age plus 5. Okay. We'll now say print new age. Okay. Now let's print this and watch. What is your age? I could say maybe 25. And you see, it throws up an error and it tells us can only concatenate string and not, that can only concatenate string, not integer to string, okay? So it means that we need to process this, all right? So yeah, that is what we're going to be talking about in our next session, how we can avoid this particular type error. But I'm sure with everything I've actually explained here, we can really have an understanding of how to input the user input. To use what we call the input function, which is just the input to pass in your term or what you're interested in getting from the from whoever you've prepared this for. And then, of course, it's definitely going to display on the results, okay? All right, so we'll look at the next part. Now, this is what we call type conversion, okay? So we kind of just look at this type conversion. Now, remember, input always gives you a string. So if you ask someone for their age and you want to do math with it, you need to convert the text into a number first. So this is called what? Type conversion or casting. So just like we said, age is equals to input, age, enter age. User enters with 5, age is equals to this. This is what it is. We need to put age is equals to int, or can cast it with int of enter age, okay? And no matter whatever, it's going to give you what? An integer. And then you can now print each plus one or whatever. So this is just basically uh, how this works, uh, provides you some kind of clarity on what you expected to do. So int converts to a whole number. You can convert it to float. Float converts to decimal. To string converts it to text string. Okay. So still on type conversion. So what we are going to do right now is that since we have this here, what we can do now is we can just force in an int here. We can say int, we wrap it with an int, and then we'll print that. It asks us to enter your age. I'm going to click 22, and then it returns 27. Okay, so the only thing you need here now is just kind of add the int method or the float method or whichever, depending on what you want to do, okay? All right, that's how it works. So we're going to actually perform some kind of basic operators in Python. We'll perform some kind of basic mathematics in Python. So Python can actually act as a powerful calculator. You can perform arithmetic operations, directly on numbers or variables. So these are usually what we call arithmetic operators, okay? So they can, work exactly like math, like kind of exactly like a kind of math class only. All right, so we could do minus, we could do modulus and all of that. So I'm going to show you what all of these represent. So when you say A is equals to 10, you say B is equals to 5. Some of the mathematics you can, operator references you can perform is you can perform addition, you can perform subtraction, you can perform multiplication, you can perform uh, division, you can perform some power function, and you can perform some kind of remainder function, and yeah, more like remainder arithmetic, okay? So this is power operator, rather. I think that's kind of a better word to use. So what I'm going to do now is, as usual, I'm going to say x is equals to 7, y is equals to maybe 5. We could say print for the addition. We could say okay, I'm just trying to think of how to. Okay, so I'm gonna say x plus y. Okay, and I'm gonna print it. This is going to be for our subtraction. So we're gonna, so for subtraction, we're gonna print x minus y. For division, we're gonna print x divided by y. So we're gonna print x, we're gonna print x modulus y power. We're gonna print x raised to power 2. So we're gonna print this, and that's it. All right. So this is how it works. This is our minus, plus, and all of that. Okay. Now, so we can actually ask the user to, I'm just gonna take this practice and see how we can perform that real quick. Of course. So let's say we ask the user for two numbers. Okay, I'm just gonna go through that. And let's see, first num is equals to impute, enter the first number. Okay, second num is equals to, and then so what we're going to do right now is we're going to say, okay, we're going to print int of, let's say we want to print int of first num plus second num. I don't know if I'm right. And I just want to be sure. Okay, enter the first number, 23, second number, 45, and that gives us it. So 23 plus 45, okay? I hope that's... Now, you find out that when we perform this operation this way, right, uh, it kind of seems like what it does is that it just concatenates it together, okay? But that's not what we want, all right? That's not what we want. So we could just put this first num and second num. Then we can now wrap it with an int. Okay, and then wrap this with an int. Okay, and then we can actually print first num times second num. Don't print uh, first num minus second num. We can print, I think that's that. And I think we just perform that. Ask this to enter the number 45, maybe 9. And that's it. So 45 plus 9 is going to be 54, times 5 is going to be 4, 5, and then subtract it from second num is definitely going to give you 36. Okay, so this is just some understanding of, basically what we are doing. Okay, so this is remainder. So what do you mean by remainder here? Modulus is that this remainder, it gives you the remainder after you've performed the operation. Look at this here. When we did x remainder 5, and this is 7. That is kind of when you do 7 divided by 5, it's going to give you it's going to give you it's going to give you 2 point something, right? No, it's going to give you 1 point something. Okay, 1, then remainder 2. So that is just what it is. Okay. Yeah, so it's actually very important for us to understand that. But let's say this was 5, or this, let's just convert this to 7. It's going to give you zero. Remainder, zero. So that is what that particular function serves as. So it just gives you the kind of the remainder that you have. Now we're going to actually look at comparison operators, okay? Comparison operators let Python to compare values, and it's always some kind of, you know, you try to compare two values and always return either true or false. So just think about it as asking Python a question. Is 10 greater than 5? Python could tell you true. These are the foundation of decision making in code, okay? So anytime we have something like equal to here, it means the equals to sign. If it's one equals sign, then it means it's an assignment operator, okay? If you want to say not equal to, you use this. This is not equal to. 10 is not equal to 5, and 10 is equal to 5. This is this. You could say print 10 is greater than 5. This is less than 5, and all of that. And then not equal to or equal to. Okay. So we're going to make sure that we don't confuse assignment operator storing value with comparison, because it's one of the mistakes a lot of people make. I'm just going to create a markdown right now, and okay. Uh, so inside of this markdown here, I'm going to say, okay. So instead of this markdown here, I'm going to say, cool. Let us print. Let's say A is equals to 6, okay? And B is equals to 7. So let's say A is equal to 7. This is what? False. We can use the word print. Now, what this means is that A is 6, B is 7. They are not the same, okay? So this is what we call the what? The equals. Okay, I'm just kind of. So this is what we call the equality what? Comparison operator. Okay. Of course, say A is equals to B. We say print. We say print B is greater than A. Okay. We could say print A is greater than or equal to B, and so forth and so forth. We could say print uh 40. 40 is greater than 60, 69, and all of that. So you're going to see the first one is A equal to B, that's false. Is B less than A? Is B greater than A? That's true, returns true. Is A greater than or equal to B? That's false. Is 40 less than greater than 69? That is false. So this is what we call what comparison operator. Now, one of the things I want you to understand here now is that when you say B is equal to 1, and you see C is equal to 3, print B. Let's see what happens. Now what happens here now is that this is what we call, this is supposed to be what we call an assignment operator, all right? And it's supposed to be 1 equals. Do you understand? Go say print B, print C. So just pay attention now. Now this is what we call an assignment operator, right? But this is different from when you're now doing kind of a conditional logic. When you now say print B now is equal to C. Now watch, it's going to tell you false. But if you say B is equal to C, that's going to give you a type error because you can't assign. But for you to make this comparison, you can say this, and of course it's going to work. So you're saying here that okay, all right. So just like as I was saying, uh this is something very, very, very important and vital for us to have in mind. Because when you say B is equal to C, you're trying to use an assignment operator for that. That is how it works. Okay. All right. Now, so we're going to actually move on to the next part. Also, this is less than or equal to, greater than or equal to. So these are actually conditions that we need to use. But the most important thing we need to get here now is we don't need to confuse assignments with comparison. So the next part of our lecture now is going to be if statements, okay? Making decisions and, understanding. If statements let your program make decisions, so it checks the condition. If the condition is true, the code inside runs. If it's false, Python skips it. So think of it like a fork in the road. Your program chooses a path based on the situation. And the analogy here now is think of a traffic light. If the light is green, you go. Python works the same way. If the condition is true, it executes the block of code. The indentation here is critical. Python uses indentation to know which code belongs inside the if block. Right? So I'm going to show you what that means. If you take, for example, age, you could say age is equal to age is equal to 18. If age is greater than or equal to 18, you can print this. You can vote. If it's not, you can. So I just wanted to actually understand this because sometime later in this video, we're going to talk about ternary lists, if ternary operators and all of that. But if you don't understand how this part runs, it's going to be a very big situation for you. All right, so let's actually look at this. So we're going to call this our if else logic statement. Now, let's say, for example, we say we ask our user age is equals to, we give an input. Remember, I'll say ask the user to input, enter your age. Okay. Now, this is where our if statements come. So we can say if the user age is greater than, remember, we just talked about conditions here, our comparisons here. If it is greater than or equal to 18, right? Now let me tell you something. Every time you use a function, right? A function, particularly like this, you must end it with a colon. Do you understand? And then you indent. You must end it with a colon, each line of the function. And the more you continue using, doing this, you will get to understand very much well in depth how to do it, how to, cast your functions and all of that. So yeah, I can actually ask it here, it's a print, you are an adult. What's a print? Please go and vote. Now, how about if the person enters 10? We can't just leave it that way, right? We can support it with what we call the else statement, okay? So the else, we're not going to put anything, it's going to print, uh, you are not qualified to vote. Okay, so we're going to run that and, okay, so enter your age and we're gonna say maybe 91. You are an adult. Please go and vote. Now, what about if we run this again and we enter -9? What happens? It will tell us you are not qualified to vote. But then, if we go back here to the next line, you saw that we have what we call an if-else statement, which is what adding an alternative. So an if statement gives your program two parts. One is if the condition is true, and one is if it is false. So you can also chain multiple conditions using elif, what we call elif. Okay, so it's short for else if. So more like an if-else example is, so for example, if it's greater than 18, just like we did, you can vote, else is print you're too young to vote. But then what about if there are other conditions you want to also put into consideration, right? Maybe probably like in this case here, okay, if your grade is above 90, then you have A if it is greater than or equal to 75, but then it's less than 90. Then what will you do? You go to grade B and all of that. So these are multiple conditions. You see that here now, only an else, if an else is not going to be enough because we have other categories that we're interested in, okay? So like here now, maybe let's say for example, what if somebody enters 0? Okay, what if somebody enters 0? What are we going to do? In that case, it becomes an issue. So we might have to do what? We might have to now look for a category to fix that. So what we are going to do now is I'm just going to kind of copy this, paste it here. So we're gonna call this, no, we can add a markdown here, and I'm gonna see if else adding an alternative, okay? So we can now see else if here we see user age, maybe the person enters 0 or the person enters maybe is less than or equal to 0. Then what are we going to say? We'll say print you entered the wrong age. Okay, so we kind of modified our statement. I'm also going to do another one. And I'm going to kind of print this, say enter age, you're going to enter 0. I'm going to say you entered the wrong age. Okay, so if I'm going to run this again, I'll say maybe minus 90, and kind of run that, you enter the wrong age. We try it again. So if we try this time, This time around, if I enter again, I will say we print 4, and then by 4, it doesn't satisfy this condition. It doesn't satisfy this condition, then it drops to else. Now, but somebody might ask, what about if you enter a string, maybe like first or something? It's going to throw up an error because this is an invalid literal, okay? And we're going to actually show you on the later parts of this video how you can handle some kind of wrong data type input, okay? So there's what we call the try and accept error. And we can say try, uh, okay? So we're going to wrap this here, and then we'll now say maybe accept. So we're going to put some kind of value error. We'll say print, please enter the right, uh, the right, please enter a number. Okay, so when we do this, and the person enters whatever, and you enter it, so it's going to tell you, please enter a number. Okay, so if we run it again, and you put 6, you are not qualified to vote. Okay, so this is also another type how we can handle errors and all of that. But for the sake of this video, I think what we need to understand here now is we need to actually pay attention to the intentions. It's a try and accept block. I just kind of threw this in, but the major important information here that I want us to understand is the if else conditional logic, where you enter a statement here and then you make sure you also enter another alternative. There's also what we call the for else statement, but all those are definitely going to become complex for the sake of this video. So this is for grade. I'm just going to copy this. I think it's something important to look at. If you look at the score is equal to 75. If score is greater than 90, then you're going to give us grade A. If score is greater than or equal to 75, that means it's not greater than, it's not equal to 90. So that's going to be B. C, then for 60, then else F. So if you run that, it's going to give you B, okay? So in this case now, we didn't ask for input. So we can turn this score here to say int input. We can say, please enter your exam score, okay? And then when I enter, maybe 99, okay, sorry, my kernel is trying to run. Enter a score, I enter 44. It gives me F. I enter again, and I enter 67. It gives me C. And I love that, okay? So that is all that you need to know for the if-else statement. Now we're going to look at another crucial part, which we call the for loops, okay? So for loops is all about repeating actions, okay? So a for loops lets you repeat a block of code a set number of times. So instead of writing the same line 100 times, you can write it once inside a loop. And yeah, so you write it once inside a loop. So just kind of think about it as a conveyor belt, okay? So it just kind of keeps going until the job is done. So basic loop range, can say for I in range of 5, print I is therefore going to give you all the numbers. So what this does is that it generates the numbers from 0 through to 4, but it's not going to include 5, okay? Because Python always starts counting from 0. And kind of going to show you what this is and how to also loop through a list, okay? But then that's when we talk about some kind of data structure, which is lists and all of that, okay? Yeah, so we're gonna actually do some kind of printing a multiplication table of 3. 3 times 1, 2 to 3 times 10. Okay, so we're going to show you how that works in Jiffy. So the first thing we're going to do here now is we're going to say for I in range of 10. Now, this is a function, so you end the colon. We're going to say print I, and it's going to loop from 0 to 9. 0 down to 9. Now it's not going to include 10 because Python runs, this is just basically how Python does. Okay, so Python counts from 0 to 9. All right, and that is how it works. So it counts from 0 to it starts counting from 0, and that is that. Now we're going to show us how to look through a list. You can see kind of something of apples is equals to now we can see something like children names is equals to Ada. Then we have maybe Chioma, and then we have James, we have Sarah, we have Michelle. Let's say for now, I'm gonna say for child in children names. So we're gonna kind of print child. Okay, so we can see something like, so kind of want to print okay, to see maybe child. So what happens here now is that it's gonna, for child, it's gonna loop at the first loop, Ada. We're gonna loop at the second, Chama, James, Sarah, Michelle, and then that is that. So it kind of loops out to children, and uh, and that is how it works. Okay, so we have for child and children names, it has to print child, then kind of Ada, Chioma, James, Sarah, Misha. So kind of loops around the list. Okay. No, the next one we're going to look at now, we're going to look at while loops, and while loops kind of loops until the condition changes. So a while loop keeps repeating as long as a condition remains true. Unlike a for loop, which runs a fixed number of times, a while loop runs indefinitely until something changes. So we'll kind of use it when you don't know how many times you need to repeat. And I'm just going to show you an example. Uh, for example, we could say count is equals to 0, and then y count is less than 5, print count was equal to 1. And then that is just basically that. So it's gonna kind of print out and kind of output for us. So just kind of always make sure your while loop has a way to eventually become false. If not, it's going to create kind of an uncountable, an accidental, infinite loop. So it's very difficult loop to actually handle, there. So count is equals to 0. I'm going to say y count. Y count is with less than 8, you're gonna do 8. Now remember you do the colon because it's a function as well. Just like the first statement, if all of them has to end if else, you must end with kind of a colon. And it just kind of come down. I'm gonna say something like count, because here I'm gonna say print count, and I'm gonna say count, count plus count is equals to count plus one. Okay, so we're going to look at this. So count is equals to 0. It starts at 0. While count is less than 8. So it moves here. It brings count plus 1. It takes the first one. The first one is count is equals to 0. So 0 is less than. So it brings that count 0. Then again, it moves count plus 1. It moves back again. Count is still less than 8. So it prints that 1. It comes down again. 1 plus 2 goes up again. Count is still less than 8. It's 2 now. So it plays count 2 plus 1, 3. That way it continues until you get to 6 plus 1. Count is less than 8, which, okay, it brings here count 6 plus 1, 7. Comes again, 7 is less than 8. 8 is brings this 7. Count plus 1 is 8. And when it comes back here at 8, 8 is not less than 8, so it stops immediately. So that is how it works, okay? So this particular syntax here, you can also do some sort of stuffs like we can do count plus equals to 1. And of course, it's still definitely going to work, okay? Count plus equals to 1. So, so always make sure your while loop has a way to eventually become false. If you accidentally create an infinite loop, press Ctrl plus C to stop it. Count plus 1 is shorthand, which is usually count is equals to count plus 1. So every loop has a cycle and all of that. So yeah. So another thing we're going to be talking about is lists. So a list is just kind of like a shopping bag, that holds multiple items in a specific order. So instead of creating a separate variable for each item, you store everything in one place and access them by their position, which is their position index. So lists are one of Python's most powerful and frequently used tools. Creating and accessing lists, numbers is equals to 1, 2, 3, 4. Okay. So list is just kind of one of the type of data structures and all of that. Lists are one of Python's most powerful and frequently used tools. Creating and accessing lists. And then numbers is equals to, let's say for example, now we've got numbers inside of a list, and we've got fruits inside of a list as well. Now we kind of looking at how to access each number inside of this list. And so for example, we have numbers, right? So this is kind of the first index. So the numbers 1, 2, 3, 4, 5, right? Fruits is equals to apple, banana, cherry. Print numbers 0 and all of that. So I'm just going to show you how you can access some kind of items, indexing of this list and all of that. But the most important information we need to actually have here is that there are kind of useful list features. You can check the length. You can look through a list. A list can hold a data type or string, even other lists and all of that. Okay. So we're kind of going to try several of these, check some indexing of this list, check how we can slice this list and all of that. So So the first thing I'm going to start with here now is I'm going to say numbers. Okay, I'm going to say numbers is equals to maybe one, this. Okay, I'm gonna keep them and stuff like that. Okay, I can print length of this list. I'm going to use the length function. I'm going to say length numbers. So it's going to tell me that there are 7 items contained inside of this list. If I add more, maybe for this and that. Okay. So if I execute this code, shift enter, it's going to tell me there are 10 items inside of this list. Okay. Now, if I want to access, if I want to access the first index, which is this first one. Now watch, we're going to use print numbers of 0. So we use the block list, that's the list block, that's the block, uh, square block to access this particular first index. That's going to be 0. And when we print that, it's going to give us 10, 8. So I'm going to comment this out so that you can be able to see that. So it's going to give us 8. I'm going to type here. Let me rather add the first index in the list is, so here I'm going to call it second index in the list is. Now I'm going to start with 1. Okay. I'm going to say third index in the list is 2. Now this is it, 814. You can see that. So Python starts from 0 to count. All right. Now, is there another thing we could check out about this list? There are also other characteristics of this list. We can append. I could do a new list is equals to, I could add other item. I could say uh, numbers dot append maybe 30. Okay, I could say print new list. Oh, sorry, I'm trying to. Um, okay, if we say numbers, and then we'll print numbers. Just to be sure our terminal is working, so we're gonna run all and of print. Okay, I just want to print a random something and print random something. Okay. 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 Thank you. So that's it. So you see, the more I continue to add, it continues to add some kind of 30s, 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 30s there. So if I change this to remove, oh, sorry, I didn't spell it out correctly. Remove, I'm going to print to be removed. It's going to remove, remove, and remove, and remove. So that's basically what happens in your list. And yeah, So we can still loop around this list. Also, that's definitely gonna happen. We could say for num in numbers, print num. So it's gonna print loop around this list and print all the numbers there. Okay. Length of, can say length of numbers. And of course, it's going to tell us 10 items inside of there. So there are a lot of things basically we can actually perform inside of a list, but it's quite important for you to know that, yeah. And this can also hold other data types. I could also mention that. We could say surnames is equals to, then we say age of 4, then we have Stanley, then we have Chijioke, then we have Mane, and we have maybe Ikechukwu or whatever, okay? Or Ikechukwu, and because of print, could say for name and surnames, okay? Remember, you leave a colon, you could say print I love, then you can put some comma, and then say name. So this is going to return I love HFO, I love Stanley. It's definitely just gonna loop around it and print out all of this. So you can just practice a lot of practices out there to make that clear. So the next one we're going to look at right now is list operations. Okay, I already started trying to do that. Numbers of appendix, I did that already. Dot remove, I already did that. Dot insert, dot sort. Sorry, excuse me. Dot insert, two numbers can actually add two. Yeah, so basically, so here now what this does now is that you have a list that has some certain numbers, so it's kind of actually insert that specific position at index 1, which is second position of a 1, 2, 3 list because you have a 1, 2, 5. All of that. So there are quite a lot that can happen on your list. You append, you remove, you sort, you add, and yeah. So let's kind of check out that, modifying list operations. And as well, I'm going to put a mark down here for proper commenting. And so I could just say this now, all kind of names. Maybe not this time around, this is numbers. So could you say body mass? Mass is equals, let's kind of use a float. Could say 90 point this point 2, we have 45.3, we have 34.2, we have 110.0, we have 67.0. Now, what this means now is that we can have a new BMI is going to be equal to body mass dot append maybe 56 points. Hold on. So we kind of print new BMI to see what is going to give us. New BMI. It says none because we're trying to assign this to this. Okay, let's kind of leave it this way. And how about we just print this because we're going to store that in a variable. We'll kind of print. I think my shell seems to be. Okay. And so what we've done here now is that we've appended this here. So we can try to But how about we sort it? Okay, this is, I'm going to call this append. I'm just kind of repeating what I said before. Mm, We'll see. We could say, no, not here. We could say remove and dot remove X not in list. Okay, probably. Just to be sure this appended. Print body masses. Let's see. Okay, it has appended. And so I think this is going to work now. Dot remove um, this this run and this should run. Mm, Not in list. Okay, let's try 45. Okay. What happened is that we reassigned it again. That was why. Oh, sorry about that. Um, okay, so we could just pick this. Hmm, So we're gonna print body masses. Okay, 45.3 is not there. I'm sorry, I'm picking the wrong value and no, it's not there. Okay, correct. That is 45.3 and that's fine. So we can print body masses. Oh, 45.3 should be there now. And why is it not there again? It should be there. Okay, let's take it up. Yeah, hold on. So this is for remove. I'm gonna delete this now. And yeah, that's it. It works perfectly. So you see that it removes 45.3. And there's also another thing we can perform here. We could call this sort. So we could say dot sort. So these are what we call list operations. Okay. And you see it sorts it well. You see how it sorted it. Uh, I could just add something like here. I could say sorted list. Okay. Remove list. And I'm gonna call this. What's the issue? So this is the added list. This is the sort removed list. This is the sorted list. Okay, so here it sorts it alphabetically. Now, how about we want to insert? We're gonna see again insert and kind of different from what we're gonna do now. But this time we're gonna use the insert method. We can insert. So what we're gonna do now is we're gonna insert at position 2. Can insert 44.4. Let's see what happens. So you see, it goes 0, 1, and then inserts it. So this is gonna call it the inserted list. Okay, let's print that. So that makes some sense. So this is what we call list operations in Python. Thank you. Now we're going to look at functions, okay? Functions is a very essential part of programming in Python. And in functions, a function is a named block of code you can write once and use as many times as you need. So think of it kind of as a recipe. You write the instructions once, and anyone can follow them by just calling the recipe name. So functions keeps your code organized and avoid repetition. So defining and calling a function, and it could say define greet and of course say welcome. Yeah, so can print great to see you. Of course, yeah. So why do you use function? Kind of to avoid repetition. You write code once, you run it many times, organize code, kind of organize code, kind of break large programs into small manageable pieces, easy to fix, change the function once it's fixed everywhere. And yeah, so we're going to kind of take an example of what a function looks like in Python because if you're navigating through data science, programming, machine learning, and all of that, functions is something that is going to be really, really, really very crucial for you to work on. Okay. So def tells Python you are defining a function. The function followed, the function name is followed by, brackets, and a colon. Then everything is indented below belongs to the function. Okay. I'm going to just create the very simplest function ever, and then I'm also kind of going to show you how you can pass arguments. I believe that's definitely what we're going to look at in the next part of this. So this is definitely going to be for functions. And how do you get started writing function? You can write the function as you start with the word def keyword. So you could say def uh, assign block. Okay, you can say print. You could just print anything. You could say the block belongs to Chioma. Okay, and say print. Thank you. Okay, so now when I run this now, it's not going to run because it's going to run, but it's not going to display anything because I haven't called it. So if I say assign block and I call this function, and I call it as many times as possible, it's going to go to print thank you. The block belongs to Chioma and all that. So if we're going to change something here, we could say Nathan. And of course, everything is going to change once. That's one of the essence of functions because you can reuse it. You can actually, you use it how you want and all of that. So that's quite fun. Now, what about we convert this function, create another function, and we call this function greeting. And then instead of this function, we pass name. Okay. Now, this is what's going to happen. We're going to see, for example, print good morning. Or can ask this function to return. Let's rather use the word return. We could see return good morning. And I'll pass an F string here, name. Okay. Yep. I think this can work. Yes, of course. So now imagine we can now say print uh so print. Now, whenever we use a return statement here, it means that it's now going to return, right? Even if we just print greeting, for example, now, it's still not going to print anything because, okay, let's say we print, we'll add Chioma, for example, now. Now, the reason why it's printing here now is because this is on uh, Jupyter Notebook, right? So automatically, anytime you just kind of call this, automatically assumes it wants to print. But now let's assume we want to have like here now maybe Daniel. You see So it's just that German that is going to print, okay? Okay, so we will need to use the word print and kind of, so each time we use the return keyword, we have to print, we have to print. But if we use the print inside of the function, then there is no need for that. So kind of print Daniel, and we can print as many names, okay? Print Lutana, can print Jacob. That's it. Good morning, Jacob. Oh, that's, you see, that's good morning. So we can just correct it in one line, only in one line, and everything automatically is going to be corrected. Now, do you see? That is one of the reasons why functions is important. But if we had printed good morning, all of that, if we want to correct this, then it's going to be very difficult because we have to go through 1,000 line of code to correct. But function makes it easier for us to wrap everything together and reuse those blocks of code. That is one of the reasons why functions is very what outstanding, particularly if you're programming in Python. So it makes our code organized, easy to fix, just like as I fixed the good morning text and all of that. So yeah. So function with parameters, I'm going to kind of show more there. I imputed name, printed hello name, hello Sarah and all of that. Of course, I just worked on this, showed you this. How about if we want to kind of perform some mathematical operations and all of that? Let's see how we can actually get that done. This is gonna call this function with parameters, okay? And I could just still perform some mathematical operation. So let's say we wanna do def of sigmoid, and for example, we're gonna consult our own sigmoid function of our own, so it's x and y, for example, and we're gonna return we want this to return maybe sum of maybe ax and y, okay? Now let's see what this is going to give us as a print uh, sigmoid 3, 5, and maybe 5 and 6. What's it going to give us? It's saying that int is not iterable. Hmm. I think something, or we misspelled something. Okay, let's say we return x plus y, and oh, fine. Okay, because of the sum, and you can see that it gives you 6 plus 5, and that's it. So you can actually perform other ones. We can see this is not what the sigmoid function is, but it's just kind of important for you to understand what we are doing. Let's say we're gonna do def of subtract numbers, and then it's going to take in 3 parameter x, y, z, okay? Now I'm gonna say return x plus y over x minus y, whatever, okay? X minus y. Let me just wrap this in a bracket so that it's easier. So this might not be subtract numbers, but it's just for you to understand that this is what it is. So each time you want to print this, because say subtract numbers, and then you must pass in 5, 6, 7. Okay? And of course, it's going to work. It's just going to perform the mathematical operation. So 5 stands for x, 6 stands for y, and yeah, that is how it works. So this is basically how functions work. Each time you want to use this method, you can just kind of call it and execute that method there. So let's say we want to calculate the area of a circle. Let's take this exercise quickly and practice it. Because say we want to write a function that calculates the area, which is length times width. Now, what is the area? If it is, whatever thing that is the area, if the area is length to length times width, let's say the area of a rectangle, let's check that online. The formula, what is the formula? That's what we need. Formula of area of a rectangle. And maybe it gives us, okay, area is length times width. Okay, that's fine. We also got that. And now, essentially, what we're going to do right now is we're going to say def area. Okay, that's area. That's enough. It's enough. So we have our length and width. Okay, and then we're going to say return length times. I think that's fine. So when we meet a rectangle that has an area length of, let's say we have a rectangle, a given rectangle that we have several rectangles that have several areas and so, but one of them, rectangle that has area is the length, sorry, the length is equals to 89, and then the area, the width rather, is equals to maybe 34. Now, how are we going to calculate this now? It's just very simple. We've established that function. So we're going to say area of maybe we pass in uh, 89 and 34. So can I just print that? It's going to give us 3026. So that's, we can just kind of add a string there. Say the area of that rectangle is this. Okay, so that's it. It's 20. So when you multiply this to this, definitely what's going to give you. So basically that is how we use function. So there's also other maybe arithmetic that we might want to look into for functions. We can perform addition, we can perform multiplication, we can have placeholders, we can change our functions. Maybe here we can also have maybe probably we can also add something like maybe a name, and maybe here we'll now see return this times this. We can see, probably we can see, let's say for example f string of maybe I could just, let me just show you something now. Maybe let's say the rectangle has names. Okay, I want to see can see name. We could see this rectangle name has an area of, so wrap this two, and so these are anytime we're passing in any method here, this might be, maybe this name of this rectangle is maybe boxy boy or whatever. And once we run that, so it's going to tell you, I'm going to create a space here. So you're going to see, I don't think we need this comment here again. Might not really need that. Just pass it here. I'm gonna say rectangle boxable has an area of this. Okay, you see it. That is exactly how it works. You pass your string and all of that, and then definitely you get that. So this is how functions work in Python. Particularly if you want to add anything, we can continue going on and on. But you need to know that the number of arguments that you pass inside of this function when you're creating this function is the same number of arguments you're going to pass in when you are calling the function. Now let's take, for example, uh, maybe I just copy this here, I could just give a random example, and I decide to maybe remove the name, whatever. I just remove it and I run it. You see that it's going to throw up an error that it took two positional arguments, but I'm now giving it three. So that is that. And the next one we're going to look at now is we're going to go into the next part, which is dictionaries. So that's a very key part of this particular lesson. Dictionaries is another type of data structure that stores data in key value pairs, just like a real dictionary where you have a word key and it has a definition value. So unlike lists that use some kind of numbered position, dictionaries, they use meaningful labels to access data. And that's what makes them perfect for structured information. Okay? So we can create a dictionary, we can create and access a dictionary. Usually, if you're going into machine learning, NumPy, Pandas, and all of that, what you're going to be passing through your data frame is a dictionary that has a data argument at the first part of your data frame constructor. Uh, you have to create and access it. And person is equals to this is how you pass information about the first person. Dictionary, this is the key, this is the value. Age is the key, this is the value again. City is the key, this is the value. Okay, so when you want to get the first index, so we're going to print person of name, so it's going to give you David, print person of age, it's going to give 25. So if you want to add a new key, you could print add a new key as person of job and job, and you assign it as doctor. Of course, it's going to update the dictionary. And you can also update, an existing key. You can try to reassign this to 26. And yeah, so the one you need to understand is that it's mutable, okay? Dictionaries are mutable. You can try to change it. You can try to maybe rearrange it, depending on how you want it to be. You can look through a dictionary for key value in person.items, uh, you know, print key value. Okay, so this is just basically you assessing the you know, kind of the individual values. That's the input and output inside of it. So dictionaries are really perfect for storing, patient profile data, records, any structured information with named fields. They make a lot of sense for that. So we'll kind of show you that in a jiffy. And kind of have this, maybe we could say dictionaries, and for example, we can have maybe this time around I could use class monitor. Okay. Now I'm going to use a curly braces. I'm going to say name of the class monitor is Cynthia. Then now remember, you're going to use colon to separate the key from the values, and then the comma to move to the next key and value respectively. So now here, I'm going to use what else do we need? Maybe the age of the person is 44. The weight of this person is 56.3, comma, and then the score is maybe 190, and then the grade is maybe pass. Now, this is what a dictionary is. And then what I'm going to do now next, if I want to print, if I want to access this particular, uh, this particular key or the value here for the fourth index, the 0, 1, 2, 3, so this is the fourth index, okay? I could say class, print class monitor, and I want to get the score. And automatically it's going to print the score as 119, okay? So if I want to access the grade, I could just print maybe class monitor, and then I'm going to pass that index there for the grade, and automatically it's going to give me pass. Now, how about if I want to loop through this list? So we're going to say for x, y in class monitor dot items. Okay, Remember, you drop a colon. This is it, you drop a colon. So you can call this key value, whichever one you want to call it. So print X and here you have brings X and then Y. Okay, so that works. And you have name, Cynthia, age, this, weight, that, and all of that. Now, how about if we want to uh, kind of update this list? I want to add or remove some people from this list. I mean, we kind of want to remove. Now, what we're going to do now, we're going to add, we're going to update, and we're going to remove. Okay, so these are the three dictionary operations. I'm going to call this maybe we can call it, maybe we could call it dictionary operations. Now, how we're going to do that now is I'm going to say print. Now print. First of all, I'm going to say class monitor. And I want to add, what do I want to add? I want to add their, maybe probably a new key. And I'm going to add maybe height. And I'm going to add it as 1.76. Let me just print class monitor so that you see that that's added. You see that it has been added. Height has been added. Okay. Now let's say we want to update the name, want to change the class monitor from Cynthia to Chiamaka and all of that. So we could say class monitor. Then we can add, we'll call the name, we'll call the key. We're going to assign that key now to Chiamaka. Then we're going to print class monitor and you see automatically it has updated it. Okay, so I'm going to say this is updated class monitor. Okay, this is what I call this added class monitor feature. Okay, so that is basically how it works. So this is just it. Now, how about if we want to remove? I'm going to do that in another line. And if we want to remove, so we're going to do, class monitor dot clear and of course when you print class monitor is now an empty list. Okay, so we've cleared the list. Okay, so I'm just gonna just print empty the list. Okay, so if I click that, so empty the list, so it removed everybody from there. Now, but how about maybe we run this? Sorry, I didn't want to run all. Print welcome. Oh, good, best food, good. Okay, so let me just kind of print something to be sure this is welcome. Okay, it works, window error. And one more kind of, okay, all right. So now let's assume we want to maybe remove a specific item from this list. Okay, so just like we did here, so we could just say class monitor dot, uh, we could say dot pop, and we will say maybe name. Let's see what happens. Okay, so this kind of pops out the name and class monitor. So you can actually see that it has a lot of methods uh, that you can actually access all of here. You can clear the list, you could set default, you could sort from keys, you could, you know, kind of do a lot of things. And maybe we'll have name dot, maybe the name is gonna, so, so we kind of just try to access this name. Okay, we'll change it to age 44. Okay, we've removed the name. That was what we did here. Pop, we removed the name. And let's see class monitor, what it looks like now. Class monitor and beautiful. So if you want to remove uh, an individual item, that you could just use dot pop. Okay, so it's going to remove it. So dot pop, we remove name is out, we have age and all that. So to confirm that again, if we do kind of class, if we do class monitor and then dot pop, and then we remove maybe score, and let's see if we can pass two arguments there, and then let's kind of check what is left in class monitor. You see, um, so we have the grid is out. We've taken out the grid, and we've taken out the score, and I guess the grid. Yeah, I think the grid is about to get out, and also the grid is, so if we do class monitor dot pop uh grid, I'm gonna say grid pass, or if we do class monitor, automatically see that the grid is also out. So that is for the pop. To remove it, if you want to clear the entire list, you're going to use dot clear, and of course it's going to take out the list. So there are actually a lot of other dictionary operations. We can do dot get and all of that. Yeah, quite important. So that is that. I already told you how to update. Uh, the key must be unique. If you assign a value to an existing key, it overwrites the old value. It doesn't create a duplicate. So dictionaries are usually very perfect for storing profile data, settings, records, any structured information with field names. So we could just kind of look at a mini project right now. Let's put everything together. Maybe you could use input. maybe just kind of collect patient's data, you use a function and kind of do that. This is an exercise I'm going to leave with you, but let's see if we can actually attempt that. Probably, maybe let's see what we can build within the next second before we go into the next part of this particular video. And yeah, just to get some ones also dating. August. Okay, so let's see what we can do based on what we've gotten here so that everything could sync. And first of all, like I said here, we want to put, right, kind of create a risk profile. Where we ask, we create a function, maybe we'll create a function, then we ask the patient to, give us their name, their age, then, if the age is greater than 50, then we can print name is high risk and all of that. And then if it is maybe less than, if it's less than 50, then of course. So remember the first thing how this thing runs is that if you look at this example, I'm going to show you something right now. Look at this example here now. Uh, the function is going to be the first thing that's going to be called, right? Uh, it's going to run in this manner. So if you call this function, this one is going to first of all run. In short, once you drop this now, before you call this function, now the first thing that's going to run is this, because this name is not inside of this block function. So first of all, it's going to say impute name, impute age, impute your name. Of course, you input your name, uh, you input your age, and then now when you now call this function, that name and age will now go and clip here. It's not going to say if your age is greater than 50, print the name is high risk. Then you print maybe schedule follow-up soon. That's if for the ages greater and all of that. Then also gonna print name is low risk, routine checkup and all of that, okay? So we could just see what we can do right now with basically what we've learned right now, kind of create a patient's risk checker. Yeah, so that I don't think there's any other thing that we need because we need to put everything into real world practice. So that's that. So, like I said, we're gonna kind of do a practice example. Let me get that. So we'll call it the patient's risk checker. The other things we're gonna add inside of this project before we go into the next part. So here we're gonna say, first of all, anything we print is definitely gonna work, okay? So we're gonna create a function, and this function is going to be uh, risk checker or whatever you call it. And it's going to take in name, it's going to take in blood pressure, it's going to take in age, and it's going to take in maybe what else could we give it? We could give it maybe some sort of stuffs like what will make it slightly complexity. Probably it can take in age, blood pressure. I think that's quite okay. You can work with that. And then you're gonna see here now that if the maybe the name the age that it enters is maybe greater than or equal to maybe 50 or 6 7 16, then we're gonna see is greater than this thing, and maybe we can say and blood pressure is greater than or equal to maybe 100 or maybe 140. Let's do maybe 120. I think that's okay. So we're gonna print maybe so we're gonna use an F string, or we can return. Okay, whichever one is gonna work. We can print or we can return. But let's print. So we can print you are aging, or you are aging. Please go for a checkup. So, but what's the essence of this without? What's the essence of this F string without this? We can pass in name. Okay, and then if age is greater than maybe 60 again, and maybe the blood pressure is less than 120, then we can actually say that I should print uh, name. So we could say the name go for, we could say, please Mr. or Mrs. Whatever. Go for a quick checkup. Now, what else we could say? First of all, we'll print, we'll welcome, then we'll say, we'll put an F string, we'll say, good morning, name. Mhm. I think that's better to have it there. I could say print good. Maybe if it's in the afternoon, so welcome, name, and yeah, I think that's much better. What do we say? Welcome, name. And what if, which other condition this is greater than or equal to? So let's say if age, I think that's a much more condition. Let's just keep it simple. Else we'll say print, we'll print F, and we're gonna say um, maybe we could just say welcome, name, we'll print again. No need for this F string. I don't think there's any need. Let's go ahead with your life. Okay, so that's it. So now what we're going to do next now is we're going to print now for name, the variable now, which is the first thing that's going to come and take here. Now we're going to say impute, please enter your name. The next one is going to be blood pressure. It's going to be because of floats of input. This entire blood pressure, and then age is going to be equals to int of input. Please enter age. as at your last birthday. Okay, so the last one we're gonna do is to call the function, and then they will not call the function, so the function is gonna be risk checker. Mm, have to pass in name, pass in blood pressure, and we pass in age. So please enter your name. I'm gonna enter David. No, I'm gonna enter Samuel. Enter your blood pressure, 45.6. Enter your age as of your last birthday. Let me say 25. Welcome, Samuel. Please go ahead with your life. Okay, so you see our program is running, and I'm gonna try another one. Enter your name. I'm gonna say Richard. Enter your blood pressure. I'm gonna say 115. Enter age as of last birthday, 78. Gonna say just go for a quick checkup because it satisfies this, okay? Age is greater than or equal to 60, blood pressure is less than 120, and yeah. So now let's take the last one. I'm gonna say, please enter your name. I'm gonna say probably Michael. Enter your blood pressure. I'm gonna say 200. I'm gonna say enter your last birthday. I'm gonna say 61. And that's welcome, Michael. Michael, please go for your high intensive checkup. Okay, so that's that for this particular session. I think that is really very important for you to continue to get. And if you really enjoyed this particular session, I just wanted to kind of give a like to this video, subscribe, and of course, yeah, do enjoy and get the very best out of what we are doing in this particular session, okay? So that is definitely going to be that for beginners. Uh, I want to actually kind of take you through another part of this session, Python for machine learning, part two. Definitely this is what we're going to be doing, and it's definitely going to be coming up in a jiffy, and quite very important for anybody that's ready or interested in getting started with machine learning. But then I want you to actually take through these practices, uh, kind of enjoy this, solve, and basically get the very best out of it. And of course, we'll see you in the next one. Bye-bye.